In this notebook, I'm explaining experiment 2, which is feature selection and feature extraction. So the first question, I have imported the data set in the data frame. And for the second question, I have dropped the columns for TOR and POVAG guarantee because some features in the data set is not required for the further analysis. So we got the output, the size after dropping. And for the third question, I have identified the outliers. Outliers are extreme values that differ significantly from the rest of the data. To detect outliers, the IQR method is used. This step includes calculating the first quartile and third quartile. And I've used the formula IQR is equal to Q3 minus Q1. And if values falls outside this range, they are considered outliers. Columns containing the outliers are identified and removed to ensure better data quality. So columns with outliers is shown in the output. And for the fourth question, I have calculated the variance. Variance measures how much the values in a feature vary. If the variance of a column is very small, it means the values are almost the same for all records. The feature provides a little useful information. In this experiment, columns with the variance less than 10 are identified and removed. So in the output, we got the variance which is less than 10 columns. So removing low variance features improves model efficiency and avoid unnecessary computations. And for the fifth question, I have identified the input columns and have calculated input columns with less than 0.2 correlation. So correlation measures the relationship between two variables. The correlation coefficients ranges between -1 and +1. +1, which is having strong positive relationship, -1, which is having strong negative relationship, 0, it is having no relationship. Here, the correlation between each input feature and the target variable price is calculated. Features with absolute correlation, which is less than 0.2, are considered weakly related to the target. These features are identified because they have little influence on predicting the price. And for the sixth question, I have dropped the columns with a correlation which is less than 0.2. After identifying the features with the weak correlation to the target variable, these columns are removed. Removing weakly correlated features helps to reduce dimensionality, improve prediction accuracy, and simplify dataset. This process is a part of a feature selection. And for the seventh question, sometimes two input features may be strongly correlated with each other. This means both features carry similar information. When correlation between two features is greater than 80%, they are considered highly correlated. Keeping both features can lead to multicollinearity, which negatively affects machine learning models. Therefore, highly correlated feature pairs are identified. And for the eighth question, from each pair of highly correlated uh, features, one feature is retained. The decision is based on which feature has a strong relationship with the target variable price. This feature with a weak correlation to price is removed. This helps reduce redundancy while keeping the most informative feature. And for the ninth question, in machine learning, data is divided into input features and target variable. So the input features are the independent variables used to predict the output. Examples, age, KM, HB, weight, and tax. And target variables, the variable that the model tries to predict. So in this data set, the target variable is price. Separating X and Y prepares the data set for training and the machine learning models. And for the 10th question, I performed univariate feature selection using chi-square. Univariate feature selection evaluates each feature individually with respect to the target variable. The select K best method is used to select the top features. The chi-square test is applied to measure the dependency between each feature and the target variable. Here the value k is equal to 10, means that the top 10 most relevant features are selected. This method helps identify the most important predators for the model. And for the 11th question, I've estimated mutual information between input features and the target variable price. Mutual information measures the amount of information one variable provides about another. It determines how strongly a feature is related to the target variable. A higher mutual information score means the feature is more useful for prediction. By calculating mutual information, we can identify the feature that has strongest influence on price. So here in this output, we can see highest MI feature is age. And for the 12th question, we have performed PCA. PCA is a dimensionality reduction technique. Instead of using many original features, PCA transfers them to a smaller set of new features called principal components. These components captures the maximum variance in the data set. The steps in this PCA is the standardizing the data, calculating the covariance matrix, finding eigenvalues and eigenvectors, and selecting the principal components. In this experiment, the first two principal components are selected. This reduces the data size while preserving important information. And for the 13th question, I have performed LDA. LDA is another dimensionality reduction technique. So unlike PCA, LDA is a supervised method, meaning it uses class labels. The goal of LDA is to maximize separation between classes, reduce dimensionality. By extracting the first two LDA components, the dataset is transformed into lower dimensional space while maintaining class separability. We can see the output here, the LDA shape 50 and 1. And for the last question, images are made up of pixels and each pixel has an intensity value. In this step, the image lena.png is read into the program. Pixel values of the image are extracted. The mean of all the pixel values is calculated. The mean pixel value represents a simple image feature. Image feature extraction is useful in image processing and computer vision tasks. Thank you.